Welcome. I'm glad that I can resonate here in the cinema at last. Yet another GeeCON. Please find your seats. I'll try to stall for 10 more seconds at least. So, I would like to tell you about MongoDB, the pitfalls that surround this database, which still remains incredibly popular, for very good reasons, actually, and how to work around those pitfalls. We'll be talking about working set, sizing of the RAM. We'll be talking schema-less and whether this is actually something nice or not. What can you do? And finally, marketing honey traps. I'll try to at least, add some vinegar then. So, this actually sparked by several different companies approaching me and asking me, hey, is MongoDB good for our use case? And they had plenty of different use cases, but most of the time, they had, relational databases, and they had relations in their data. And just this alone should give you pause when you think, all right, I'll choose MongoDB. For those of you who would like to, go to the talk of Jakub, and you're now hesitating, here is the image which perhaps will help you make your mind. Mongo, convenient to use, incredibly fast to plug in. They did a lot of work to make it so. Small projects will absolutely like it. Larger projects, without due diligence, may find themselves scrambling for PostgreSQL later on. That's the case of at least several of my customers. Mongo's marketing is incredibly persuasive. It's all around us. And I will actually detail their strategy, which I sometimes call it survival strategy of the Tengen, and sometimes it's just pretty much the old known vendor's angle. Because Tengen is a vendor, and they want you to buy. So do your own legwork, prepare your own test cases, at the very least, use Jepsen's analysis that happened so far, or perhaps even employ Jepsen, pay him, and, get a new one. So let's talk about pitfalls. So the marketing or survival strategy, which worked very well, what NoSQL actually means and what it promises, and how it was very often misconstrued. Distributed databases, CAP transactions, right use, so NoSQL or relations, the post-transactions era, as MongoDB would have you believe, schemaless means actually that you will have schema in your own application or applications. Now, working set one more time, of course, the RAM for the working set, and without further ado, do you really need MongoDB? That's the first question you should be asking yourself. Number of times I've seen decisions made out of hype, decisions made out of, this is just a small application, this is a side project. If you made the decisions like that, the others did too. So number of companies who are blogging about we are using MongoDB, they are doing that on their side project, experimentally. But it makes for a good recruiting material, so if they blog about it, perhaps people will come. Now, when it comes to distributed, because NoSQL databases are distributed databases, that's one of the part of the appeal, to be honest. So, what did you do with RDBMSs so far? What clustering solutions have you considered on that side? Do you need distributed? Do you need active clusters? Plenty of times you will hear that these are very easy. Don't trust that. My name is Tomasz Borek. I am self-employed. Mitori is my own company. I'm associated with GeeCON. I'm helping with the conference, though not this year. I'm helping with Polish Java User Group, Software Craftsmanship Kraków, and Lambda Lounge Kraków. You have some links if you want to, find me later. So without further ado, audits, trainings, diving into, deep performance problems and others as well. I'm pretty much a programmer for hire, though usually I'm actually, hired as a trainer, consultant, auditor. That's pretty much. So, the promise. What was promised, what was offered? Let's talk a little bit about that. NoSQL, CAP, Mongo, distributed system, scaling, transactions, and Mongo. First, let's take a look at the word of the relational databases. It must be said that relational databases have at least half a century of growth. They are battle-tested on numerous fronts. However, they were built for a different era. They were built when reads and writes were totally differently used in different proportions. They were built when we had different servers. Our servers back then, publicly available ones, were really weak. You have better servers in your pockets, and they are called phones. So right now, we have totally different thing. But for years, that has been the case, So back in 2010, I talked with Bruce Momjian of PostgreSQL. And he said that time and time again, the customers are asking, well, we would like to have long-lived transactions. Well, we would like to have, distributed clusters, active. And his answers, and not only his answers, because a number of other vendors would actually answer in the same manner. You don't need it. Let's dig deeper into your use case. Let's see. And see, you don't need it. Of course, there was an angle in that, okay? Or there was an angle to those answers because active clusters were hard, distributed databases were hard, combining them together even harder. So of course, relational databases didn't want to go there. They didn't think they would do it well. And they had already a lot of functions, baggage, etc. Along came NoSQL. NoSQL made a lot of promises. And depending on whom you were talking to, probably for you, NoSQL means different things. Like, for example, NoSQL, like totally not a single iota of SQL anywhere. That's the most militant stance I've seen, but I've seen it. Then it's not only SQL. So we have polyglot persistence. I can actually, supply MongoDB here, Redis there, and use Oracle for the main, let's say, core of my business. Then there is no idea, actually, because I've read 3 sources and they said 3 different things. And then new SQL, so replacement for SQL, and then SQL. That's a slide from Mark Matsson's talk. And as you can see, he has mapped quite the progression, And my favorite part, I think, is this one. So he already said it in 2013. 2013 actually happens to be a great year for Mongo. DB Engines marks Mongo then as the database, like the most talked about database. DB Engines is not the methodology behind DB Engines site. It's actually mentions, Twitter mentions, blog mentions, Google Trends, and other things like that. So it's mainly popularity. Mongo was downloaded incredible amount of times then. But still, people already said that NoSQL overshot its promise, and actually SQL is here to stay. You will find a number of texts saying that SQL is just a tool to access data. And there's a truth in that. So if you take a look at most NoSQL products, they will also offer mapping. Like, yeah, we're NoSQL, but if you're coming from a SQL world, then we're actually very similar. So we talk collection, but you probably heard this as table, and you can refer to this as table. If you take a look at code for drivers, you'll find that there is table mentioned, or a cursor, or other things which are popular and pretty much lifted off SQL jargon. Now, the wise man in, 2000-something said that you cannot ignore partition tolerance. The original CAP theorem said that you have to choose between consistency and availability. Those are your choices. And this is where the schism began, and nobody wanted to be CA, because CA was where SQL was. That was consistency and availability. Nobody wanted to be there because that was uncool. So Mongo is placed over here. Consistency and partition tolerance. So the data that the clients are seeing is supposed to be the same. That's consistency. Of course, consistency is not really well defined according to the CAP theorem, and availability is really badly defined according to CAP theorem. We have managed to revisit CAP theorem like twice, and there is even a new one proposed which includes latency, because come on, latency not included in web and distributed, that's no go. So let's sum up the NoSQL promise. No relational DBs or less, or we can work with them, but we have our niche and don't use relational for it. Distributed systems, distributed databases, not single server databases. Active, so we go into clustering and each and every cluster can accept writes. That's huge. Of course, we want to be scalable in any way, in every way. And we also want to serve for big data. That was very important. Big data pretty much tied into NoSQL, like one move ended, the other began. And we want this to be a powerful tool and an easy-to-use tool. All right, so anything and everything could be plugged in here, but we at least narrowed it down. So what about Mongo? What did Mongo promise? Well, CP, so consistency. Yet, you will see a couple of slides later, they had their issues there, they still somewhat have. Then, the name itself screams big data, humongous, Mongo. So, hence the name. Now, humongous big data, so replicas and sharding. Now, sometimes people say that Mongo gives you scalability out of the box because you start with a cluster and the cluster has replicas. That's a failover, true. That's, duplicated data, true, absolutely. When it comes to scalability because of, partitioning, the horizontal partitioning technique is called sharding. So if you're not sharding your data with Mongo, then that's not what you would call scalability. Then they promised that they are good for pretty much everything, mainly for financial things, and they kept this going until 3 Bitcoin startups had really huge busts, ending with complete evisceration of a customer's fund and disappearance of the companies. And there are good arguments that this wasn't, something that could be put at foot of Mongo. Like, not only Mongo was responsible. After all, the guys from the startups, they decided to use Mongo in the way they decided to use it. They decided to keep the default settings. They decided that they don't need to enable authentication, etc., etc. By the way, Mongo took 5 versions and several years to finally cave in and decided to, change those default settings. And then there is one more thing. Mongo, sometimes in their promises, they take a nice spin on things. The famous quote, "We live in a post-transactional era," meaning you don't need transactions. Transactions were just wiped off the map because we are in a different era now. Then, of course, the customers didn't buy it. They wanted transactions because usually when you have database, you're so used to the fact that you have transactions, bundled in, that the requirements, the expectation carries even though you know that you're talking about NoSQL database, not a regular relational one. And you still are, but do you have transactions? Because you expect them to. And they're, no, we don't. So after several back and forth, they decided, okay, yes, cool. We no longer live in just a post-transactional era. We will have transactions, but only locally, for a single server. And then people were like, but we wanted you for the distributed. All right, but with limits. For example, no sharding, etc. And you need to read the docs to find things like that. So let me have a quick quiz. When Mongo completes a write in default settings, mind you, 5.0 changed those default settings, I'm talking about the earlier ones. So answer A, we have here 6 servers, the client, and 5 replicas, and the client needs to, send data to MongoDB. The question is, when Mongo has this data, when the write is completed? Answer A, it was read to everybody in the cluster. For a number of reasons, this may be bad, because clusters may be large. If every single server in a cluster must tell you, yes, I received it, No, not really. So perhaps B. Perhaps B. You know, some. At least some. Well, okay, not just some. Majority. Majority, of course, brings another set of troubles. Like, if we have a cluster and we have 12 nodes in it, then the majority is 7. But we have a cluster like 30 nodes, then the majority is 16. Of course, there are other things to consider, because in Mongo you have replicas which have vote rights and replicas which don't, and they are, you know, counted for the majority. But let's keep it simple. Now, if 3 of those got the data, then does it count that Mongo got the data? And finally, perhaps just 1. Because if at least 1 server has it, well, the server will spread it around. So, hands up for A. All right. Hands up for B. Hands up for C. You guys are good. You guys are good, but not good enough. Don't worry. I was in your shoes exactly. When I saw this post, I was also thinking, yeah, C. The truth is, the answer is D. Not even 1 server needs to actually answer and verify, acknowledge the data. If the data reached the server without the acknowledgement, it's considered by Mongo to, you know, be delivered. Of course, this meant that a lot of data was lost, and that surprised plenty of people. And there wasn't very many mentions about that in the documentations, unless you found the docs about the default settings and what they actually mean. So, replication and sharding, another part of MongoDB promise. So replication, backup copies, sharding, horizontal partitioning. In sharding, you have several servers, you spread the data among those servers. Kind of like RAID for drives, but between servers, database servers. In replication, Mongo may lose data due to elections. That's something you should know. During elections, if the old primary who has data will come back to the cluster and say, hey, I want to join again, the new primary may tell it, overwrite your old data because the new data is what I have. And then the old data will be lost. Some crazy defaults are also to blame here, but Mongo 5 actually changed the defaults, so Mongo 5 and above, and at least the rollback problems is somewhat mitigated, so take that. Sharding. In sharding, you need to remember that when you consider Mongo, you immediately need to consider sharding. Don't wait. Do not wait for case when you will be like, oh, I'm staring sharding right in the face and it screams, I'm needed. No, that's too late. You want to consider sharding when you're modeling your data for MongoDB usage. Only then you will actually create your data and create your schema in such a way that later choosing sharding key will be simple. All right, so distributed systems are hard. Distributed systems are hard because, well, what does it mean that a system is distributed? This means that we're dependent on a foreign computer. Failure of a computer you didn't even know existed can render your own computer unusable. That's the father of distributed systems, so it's biblical definition. Now, to be honest, there is a great material called network fallacies. Hands up who knows it. All right, the remaining people do read the PDF. It will take you less than 2 hours, but you will be much better programmers afterwards. So this is a great illustration by Denise Yu, which actually she liked cats and decided to use them to illustrate the fallacies. First of all, transatlantic cables are eaten by sharks because they glow in the darkness. And you know, the floor of the ocean is rather dark, so the fishes there are drawn to the light, and there you go. It was such a huge problem that Google at some point decided, okay, we'll spend a whole lot of money and put every single cable that we use in Kevlar so that it won't shine anymore. Now that wasn't all. You can actually have plenty of stories where a faulty cable resulted in a loss of connection. So reliable network, myth. Then we have latency is 0. If latency would be 0, because that's also a myth, then we would actually teleport packages. We do not. We have the entire cable infrastructure and infrared and Bluetooth and radio infrastructure and satellite internet just to actually transfer the packages between A and B. There is no teleport involved, I guarantee you that. Then we have the fact that we can carry, as in a package, only as much data. If we try to squeeze in more, the package gets splitted, and this is actually not so swell. And we could continue, right? The next part, the network is secure. As a person who works with niebezpiecznik on security matters, talk to me after the talk about that. I'm eager. Then we have changes in the topology. The client connects to the server, and they are in the same distance, but the route that the packages are taking back and forth may change between, request and response. Finally, if you're planning to install Mongo, distributed Mongo with sharding, you will need to talk to plenty of administrators. Firewall administrator, virtualization administrators, sysadmins, network people, and many, many more. And they need to be, working as an orchestra. And if they are split between different companies, that's kind of hard. Transport cost, not 0. In addition to the fact that it takes time, we also pay for it. We sometimes pay for people who make this possible. Finally, there's a lot of different devices on the internet. Therefore, we need sometimes to have translation costs, incurred. Let's take active-passive cluster. That was the default cluster that SQLs or RDBMSs were offering. And they were offering for a reason. Because if we have active-passive, this means one node does writing. And this is great, because all data comes from that node. Of course, in a distributed setting, if this node goes kaboom, we have a problem. So let's add network problems, let's add clustering problems. What is a cluster? Well, there's a group of servers where there is some sort of program or protocol which allows them to talk to each other. And usually we have software that helps in that. If this software has a bug, you have a problem. And of course, your own system. It also does something. Now, let's bring back the transactions. ACID, MVCC. Then we, of course, have isolation levels, the ANSI isolation levels. And how do we do this in active-passive cluster? Like, how do we make sure that the transaction is atomic? Well, if we have one active node, then this is where we implement most of the controls. But what if we have multiple? Now, rollback, distributed one. It means that whichever server in the cluster got my data, it now needs to get my corrected data again. So if I was doing transaction, and majority of the servers were the setting, like cluster has the data, if majority says so, then I need to actually inform that majority that, no, we're doing rollback, because somebody was faster. You don't really want active-active, as the SQL people were saying, because of active-passive problems, network, and because of concurrency. Because we don't really have good concurrency controls on any level. Now, with partition tolerance, you can't sacrifice partition tolerance, so network will split. Your cluster will split. What happens then? Before I talk about that, let's switch the tune and talk about marketing. I'm saying here that these are attacks, but let's take a look at this lovely turtle. So what a harmless animal. What bad things could it do? Of course, no bad things. Now, no more SQL, so we are using existing hype. But that's not all. Let's go with something that really sounds well, modern. Who doesn't like to be modern? Who doesn't like technology to be modern? If we're not using modern technology, something's wrong with us. Web development, so a huge market, and Mongo did several things to actually, positions itself there very well. The post-transactional future, we already talked about that. So DB engines actually say that MongoDB is number 5 right now. It was number 1 in 2013, 2014, and it was a lot of times, within the top 5. Now, on Mongo side, you will find that according to developers, they are the most wanted DB. And we all heard about MongoDB, right? So it definitely is popular. Mongo claims that they are the most popular. Now, according to DB engines, which is a good measure of most popular, in 2020, that would be actually, not Mongo, but Postgres. If you go for the most wanted, the quote I just shown you here says that, yeah, we are consecutively rated as their most wanted database. And this is a link on their site. It leads to another site with Mongo marketing materials, which says that Stack Overflow had did a survey. So you could accept this on this level. Plenty of people do that. But what I would like you to do is when Mongo claims something like that, you go deeper and check. So Stack Overflow Research Survey has this most wanted indeed in the technology section. And it says % of developers who are not developing with the technology, but expressed interest in developing with it. So I would like to work with the technology. That's pretty much cool. Most wanted, right. Mongo indeed leads. 19% of surveyed developers expressed such an interest. Well, 19%, let's round it up to 20. That's every 5th developer in the room. And did you know that there is another category? Most dreaded. And interestingly, in the most dreaded, Mongo is, well, 4th from the bottom. That's not bad, but 44%. So close to half of everybody who works with MongoDB expressed an interest in not working with it anymore. Of course, you won't find mentions of that on MongoDB sites. The mean stack is yet another reason for popularity. And this is a reason for Mongo positioning. Web development, mean. So Express, Angular, Node. Node is very popular. Mongo ties it to itself, a very good move. Mongo shell, written in JavaScript, uses JavaScript. You can actually pass your JavaScript files so that you will have your functions and you will be able to use them in Mongo shell. That's cool. JSON and BSON, binary JSON as some people say it. And of course, yup. In 20-something, there was this interesting article. At some moment, everybody decided, oh my God, American Airlines is about to bankrupt. And it was everywhere. Every single portal in traveling was talking about that. And why? Because Google made a change to their indexing algorithm, and an old story from 5 years ago resurfaced. And then everybody was like, oh, there is a story on Google that American Airlines is going bankrupt. Let's repost. And then American Airlines, did almost a crash course on the stock market. Now, what you're seeing here is a clear trend. Obviously, if you get MongoDB as your job, your future is bright. Now, if you base your future over 2 days and the growth of 0.2 percentage points, then your future will be bright. Of course, it was taken and it was posted. Mongo claimed this is a success. They posted it on their marketing sites. Business Insider decided that's a slam dunk. Really, MongoDB and the job, equality immediately. Interestingly, that's an allied press, because Merriman is also a co-founder, investor, and board member of Business Insider, and he's a CEO of Mongo's company. Wow. Guess which part of the article was quoted more? That or that? Now, if you take a look here, the peak starts dropping down. Now, Mongo was famous also for several early adopters. And if you dig deeper, you will find that those early adopters were actually having same, roots as in investors. It's even rolled back, but that wasn't heralded so much. Of course, mean and number of presentations, marketing materials, this was a great topic on Mongo user groups. Bootcamps also decided, okay, Mongo is very easy to use. And this was actually intentional. Bootcamps means juniors. And bootcamps don't really care about larger projects because juniors are not working on larger projects, at least not on bootcamps. Later, when they join the companies, sure, but initial projects are small. And Mongo was a right fit. Hackathons, of course, obviously, it was everywhere where quick and easy to use was a criteria. So Mongo went out of its way to make itself quick and easy to use. One of the first Dockerized databases, Atlas Cloud, so that you can actually not leave your browser and have a cluster of Mongo databases out there answering to you. Package manager installations for most popular Linux distributions, streamlined so that you wouldn't have problems. Number of times when you actually do, for example, sudo apt install Mongo, you get old packages. So let's have a procedure for you to follow, where you will get new packages, where you will have all issues potentially discovered, etc. Do you need to create a collection on database? No, don't worry about this. Just insert data and they will be created automatically. Schemaless, no friction, just code. Bison is like JSON but better, so REST APIs which produce JSONs are right our alley. And with that, they went even farther. This is the moment where Mongo's marketing is such a driving force that the product is absolutely benefiting from it. So first thing, try MongoDB.org. You don't need to exit your browser to actually play with MongoDB cluster and do something on it. No installation whatsoever. Then we have guides, where we have pretty much use case, how to solve it. Another use case, how to solve it. Simple instructions, just take, plug, and play. Then you have certifications and courses, some disguised as actually content marketing, but done by engineers, with numerous, small snippets of actual how to use the product, and directly, gently steering you into not using what you shouldn't be using. Then we have benchmarks, the vendor benchmarks, kind of like these, where you think, oh my God, what's a trend? Couch, you're such a lazy couch potato. And then you learn that, yeah, this was just a silly benchmark which we did to answer some blog posts which also used a silly benchmark. And our growth here is thanks to the fact that we are using unacknowledged writes. So the server doesn't even bother processing our reply. When we arrive at the server, the time measurement is done. So yeah, we're very fast. And we could go like that, right? Database making decisions, MongoDB everywhere. Or we could actually say migration, everybody migrates. Or we could continue and take a look at the documentations. That's again the benefit of the marketing. Really clear docs. Web shell, so that you can actually try the examples on small examples on Mongo in the cloud. And let's summarize, right? Press, Mongo user groups, blog posts, benchmarks, Mongo's own documentation, and word of mouth. These are pretty much the platforms where Mongo delivers the message, you need to use us. And we might say they are evil, or we might say they want to survive. The business is cutthroat, and there are many other NoSQLs who would like to take the first place. So if you want to counter that, Nemil Dalal has an excellent 3-piece blog post series where he also adds additional musings. He also has the interview with Elliot Horowitz, the CTO of Mongo. Plenty of good materials there. Read it once, you'll become jaded enough. Jepsen's analysis, employ Jepsen's tests. Design your own test, that's even better. And avoid the new tech Kool-Aid. There are plenty of surprises in Mongo, Global lock that's done right now, it's moved downwards. On the database level, you now have logs. Sometimes you may log on the collection level, but it used to be a global log. Plenty of teams were surprised. Save states feature, hidden, turned off by default because early customers wanted it. Loses data, actually, it still loses. Jepsen test, they say they are passing. They were not passing. They were not passing for thrice when they actually claimed that they were. And a lot of other things, all right? So, list of surprises for you to study later. The slides are already online. Let's talk what you should do. So, first, Jepsen. Really great piece of engineering. Those of you who are into Clojure will like it even more because that's how it was done. And let's see. You probably won't be able to see this, but let's just scroll a little bit. Yeah. What you're seeing is the results of Jepsen and Nemil's analysis, which shows you that you have problems with passing the data. Namely, all of those are isolated transactions, except they are not really isolated because you can see data and you can see how it probably, was passed around. So this is not really isolated, fellas. If somebody claims I'm fully AC'd, then I stands for isolation, and we have a problem here. Now there is more, If you take a look, there are other examples here, and let me find, yes. This totally unreadable unless you really zoom in graphic, which you have linked in the slides, so study at your leisure, shows you how large of a problem that was with Mongo transactions. This was done on 4.2.6. After Jepsen published the analysis, Mongo found several bugs, So let's take a look at the bugs that they found. Lost data when reading, that was version 3. It was fixed partially, and the Mongo documentation started really saying, if this and that happens, data loss may happen. Actually, if this and that happens, data loss should happen, will happen, but they are still saying may. Bad defaults for replication. They actually changed that partially in version 4, partially in version 5. Lost data in rollbacks, somewhat addressed from 3 to 5. Transactions not isolated. I still don't think this is fully addressed. Transactions badly retried. Actually, that was a huge issue. Number of findings from the Jepsen reports were because Mongo tried to retry the transactions. And when it retried the transactions, it didn't pay attention to the guarantees of a transaction. So, of course, the retried transaction happened sometimes, before, then some other transaction happened, and then your transaction was retried for no good reason other than distributed system being hard and not, exchanging information fast enough. And of course, when Jepsen people tried to turn the retrier off, like totally, it turned out that the option wasn't working at all. So take a look at Jepsen's test and employ appropriately later version of Mongo. That's very good. Just so you know what is Jepsen doing, pretty much simulates that the partition happens. Jepsen takes a cluster of Mongo, then makes it partition, so network is split, then fires some tests, then does things like primary went down, primary went back up, cluster healed, partition, is over, and what happens in all of that. All right, so that's one of the, illustrations about the problem. Let's take a look at this. This is a simple cluster, and in most graphics in Mongo, you will find clusters like that. These are not really realistic cluster, While Mongo introduced here actually better defaults in 5.0, they introduced right majority, they introduced, I think, read serializability, so actually much stricter defaults than usual. Still, don't do tests like that. In your own test, actually do larger cluster with more nodes and make sure that your secondary replicas, they are not, in even number, but in odd number. Schemaless, or is Mongo the right way? People often say, this is awesome because we are quick in coding. And in a way you are, but you code it in your app. You code your schema inside your application, that's the cost. Now, Russell here points out that design a schema and make it take advantage of MongoDB's features, which is said much better in, for example, data stacks documentation for Cassandra. Collections in Cassandra are supposed to be done for one single query. So when you model your application, you need to know the queries, and each query should got its own collection. And when I was reading data stacks documentation, that was a clearer message, unlike Mongo. So you are schemaless, but design a schema. Okay, what do you do? So you need to have schema in your application, and the code of your application, before constructing a query, should make sure that all the data in this query are actually cool. If you do that, all right. But what if you have multiple, clients? So schema offers structure. It offers types. It offers something like, what does this table represent? Let's take a look at the schema. Oh, I get it. Now, your data most likely has structure. Mongo was done as a database for IoT. It was done for logging. It was done for analytics. It was done for multiple sensors swarming you with the data. If you lost a couple of sensors data, a couple of readings, no big deal. But you see, the loss of data was imminent. But then Tengen realized that that's not really a huge market. The huge market is web app development. But people there don't like to lose data. So candidate, job, advert, company, connected together. Finance, transactions, A pays B for C using something else, connected together. Then e-commerce, etc., etc. Most of the times you need structure. So either your app, not really, or you use schema validation from Mongo 3.2, or even better, you use JSON schema from Mongo 3.6. When you create a collection, you add a schema validator to it using JSON schema operator. It's possible to modify it later, so if you do it badly, you can improve. Schema, JSON schema is recommended also by Mongo documentation. Of course, you can also employ Mongo as a quick and dirty solution. I've seen it happen, and I've seen it be very successful. You begin coding a new web app, you use Mongo, then at some point you realize, okay, I know now how my data is structured. Now I know. And then you move to Postgres. I've seen it done a number of times. So, modify the collection with the schema validator. This is the case where you have a collection but don't have a schema validator. Then you set the validation level to moderate. This allows you to modify old records and move the collection partially, make it valid. The action you set to warn if you want new data to be allowed even if invalid. Because perhaps there is some client which will still give you wrong data and you don't want to kill it yet. And you steadily move it to strict level where all inserts and updates are validated, and you move it to error when bad writes are blocked, disallowed. Of course, you may do it by portioning this collection. You may actually take 80% of this collection, move it to some other collection, perform this in one go, and then just replace. Working set. Working set is very, very important, and there are many factors involved. Your data growth is incredibly important, and you need to watch for that. And if your working set is not well configured, the Mongo will crawl. All the speed, gone. So what's a working set? It's what Mongo puts in memory. Most frequently used data and indices for it. Now, you will see drastic drop in Mongo performance if you actually have swaps, if actually Mongo needs to save things on the data, on the drive. But to look for it, because you won't know what's your working set before you start using Mongo for your case. So Take a look at your most often used queries. Log your queries, take a look at collections they have, indices, take a look at sizes of both. dbstats is your tool. How it changes is incredibly important. You need to take a look whether daily, monthly, you know the tempo of incoming data, you know how much your data grow. And this is very important. This is one of the reasons why you usually won't be able to estimate your working set size correctly the first time. Look into system page faults, look into Mongo statistics on WiredTiger statistics actually. WiredTiger pages read into cache, evictions of unmodified pages, these are your indicators that working set is badly sized. If for some reason you left this swap on, you should not. But if for some reason you did, the moment Mongo starts swapping, working set definitely is not all right. Now, good schema design, then queries which use indices, all of them, then good indices, then collect the usage. This is how you actually arrive at a good working set without, being blindsided by something. Already said about queries indices, counting the data. Now repeat this per query, per collection, per database. If your replica, where you're doing this, for instance, crashed and it was restarted, you need to first recalibrate all statistics prior to doing that, otherwise you'll have bad data. Some good practices: if you can cut the collection into smaller pieces, do so. If you see from the usage patterns that, for example, only like 30% of data from your collection are being used, then leave that, cut the rest to different collections like data_old, and make the adjustments in the application. If you have few queries which use this old data, use covered queries. Covered queries have a very nifty trick. They are entirely done in memory, so the index pretty much doesn't need to load data into the working set. Ideal for cases like that. Growth of your data will change. You need to repeat the procedure and adjust accordingly every now and then. And of course, the greatest weapon you have to decrease your working set is sharding. The general RAM usage nodes, that's working set, WiredTiger cache will take like half of your RAM, close to it. Then we have threads, MapReduce, and sorting. So MapReduce, all of MapReduce operations use RAM, replace them with aggregates. Without indices, a query, sorting will happen in RAM and will eat the room available for pretty much other operations. 1 thread per connection, that would be 1 megabyte of RAM. If you have multiple connections open to your database, this means multiple megabytes of RAM used to keep those connections. And WiredTiger cache, 50% RAM minus 1 gigabyte, or if this is not possible, at least 256 megabytes. Important to know here is that you can replace MapReduce with aggregates. There is rarely a reason to use MapReduce at all. Significant queries should be indexed, and you want this to be monitored, and ideally you want your Mongo queries to be taken into account and indexed, actually checked by some automatic test if they use indexes. Connection threads, of course, you need to estimate how many connections will you have. And the WiredTiger cache should be large enough that the working set would be inside, because the cache for the WiredTiger allows you to quickly write to drives. Mongo keeps your working set in RAM to be fast, but if you want persistence, you need WiredTiger cache to be able to smoothly write it to the hard drive. OS buffers, OS caches need to be operational, so you need to leave RAM for them. Mongo process will eat some of the RAM as well, and if you're using Dockerized Mongo or you put Mongo in Linux containers, then watch host info system memlimit_db. All right. That would be a good moment for you to ask questions and some summary while you do that. MongoDB, very nice, very mature product right now compared to version 2.0 or 3.0. A lot of features. They position themselves as a solve all problems database, and many have failed, which slightly put a dent in this narration. you need to check the data. There is no doubt that there is several overpromised things, but this still can be pretty much chalked up to vendor's angle. NoSQL is not really well defined, CAP theorem has been revised since the inception, and if you choose MongoDB, be aware that you need to actually take a look at least at Jepsen's analysis and do your own tests. Consider when will Mongo fail and how likely is it in your case. If you need relations, don't go Mongo way. All right, sharding is difficult. Distributed databases are difficult. If you want to go active clusters, make sure that your data will support it. There is a good case. AXA actually did sharding with a really large data set. Well, incredible amount of data, and they managed to do this because they sharded per tenant. So they did a multi-tenant system with, shard per tenant, which gave them incredible isolation and redirected the queries appropriately. Well, each time Jepsen releases new tests, Mongo documentation will get better. Mongo tests are easy to do because of Atlas, because of the try MongoDB, because other services. And finally, that's me, and let's take a look at what questions do I have. All right. You are clearly frustrated with Mongo. What happened? And the real question, do you love Cassandra? Mongo is a kid toy compared to it, right? Cassandra for the win. I must say, the person who read me so well, he must know me. Taking into account all the Mongo's problems, why it's still so popular and probably the most common document-oriented DB. Only thanks to its marketing? Well, marketing is powerful. I do believe that. Mongo's success speaks to it incredibly. But that's not all. Mongo is very easy to use. When you're a developer and you're looking for a quick database to plug into a project, Mongo begs to be used. You may know about the issues, but the temptation is still there. As a person who used Mongo in a couple of projects, I can attest to that. Compared to setting up some other databases, well, it's good to have scripts to set up other databases, then you will actually, find yourself working faster with them. MongoDB Inc. wants to make a good databases or just make money? That's a freaking cool question. Definitely they want to make money, but I wouldn't say this totally, excludes the other option. I met with a couple of MongoDB people, and they are incredibly nice when you talk to them about Mongo issues, It's really, either they are a bunch of psychopaths and they completely fooled me, or they are really nice people who genuinely care about the product they make. And that's not just my impression. One of the interesting things, even in early days of Mongo, when right now the docs are cleared up, a number of things are mentioned, even if with small font, but it's there. But earlier, it wasn't the case. And when people were angry at Mongo team, when they were, ringing their support, those people were genuinely caring enough and working fast enough that, they convinced their customers. So I do, there's one more aspect which I didn't say. When you have a product and you work in a startup culture, sometimes it's fail fast, fix fast. So you're giving a production-ready label to something that's not production-ready. Your customers pick it up. They fail with it because it wasn't production-ready, but then you throw everybody at fixes. And you get valuable feedback, and you know what works, you know how it was supposed to work, and then you're absolutely certain that you're doing this as customers want it. How's having documentation like Mongo has actually bad? I get other parts on shady marketing, but some of those things mentioned sound actually great. Oh, they do. They absolutely do. And let me be very clear here. I do believe that MongoDB documentation are really on a very high level. I do believe that Try with Mongo, University, the courses, the clear layout of the documentation, the way that you can actually quickly jump between products or versions of products, that's actually really well done. I do believe that. So if I didn't make it clear, here it goes. Do you have any thoughts about Azure Cosmos DB? Does it solve any Mongo's weakness, or is it even worse? The problem with Cosmos DB is their paying model. The way you pay for usages, the way you pay for traffic, this makes Cosmos a really weak choice in number of workflows. So thanks to that, number of people who are among my customers who are considering Cosmos went totally in a different direction, even though some of them used Azure DB. And yay, that was the last question. So if anybody has a hand in the air, please wave so I can actually spot you. Fire away. The question is, would I use Mongo personally in production? So first of all, it already happened. I already used Mongo in production. And I could use, the excuse I did it without knowing, but I also did it while knowing. The reason being analytics. I was fine with perhaps losing some of my data. I had enough of that to, analyze the trends. And for that reason, absolutely great database. Oh, thank you. So, what are the most important bugs in the newest major version? All right, so the most important bugs in the newest version. Actually, the newest version is the best of all of them, to be honest. Let's see, the retrier bug should be fixed, at least they said so, but I would still run the test. So, short answer, I don't have like one glaring bug that you should absolutely, for that reason you should go away, but I have 3 bugs that you should watch for. Retrier, transaction isolations, and security. So, well, security is not really a bug, it's rather checking that the default settings are changed as they want to be changed. I don't know if you know, but Mongo changed them only after 30,000 of databases on Atlas Cloud were ransomed, and people asked for Bitcoin there. Only then the default settings were changed. Mongo is not schemaless, Mongo has dynamic schema. Documentation claims that. True, the early documentation, however, called it schemaless, and that's still the hype that marketing is not, not saying anything against. All right, thank you guys.